Hello Year 10. As you are aware, you have some assessments next week. And so I wanted to go over today all things to do with triangles. The reason I want to go through all things to do with triangles is because last week I sent you a revision test, and it was on the sine and cosine rules. Now, hopefully you have committed to memory what those are, but I want to remind you about them, and then I want to talk about other things that are important to remember when we are working with triangles. So, sine and cosine rule, first of all. We take any generic triangle and we label the sides and we label the angles. The angles we label with capital letters, and we label the opposite side with the same letter but in lower case. There are two versions of the sine rule. We can have sine A over A equals sine B over B equals sine C over C. Or we can flip all of those fractions and have A over sine A equals B over sine B equals C over sine C. We only take sine of the angles. So sine is of capital A, which is the angle. It is not of little a, which is the side length. So that is the sine rule. You should commit that to memory. This rule is useful where you've got two angles, say, and one opposite side, and you want to find the other opposite side, or two sides and one opposite angle, and you want to find the other opposite angle. If you have two sides and the angle you want to find is between them, the sine rule is not going to be useful because you would need this side or this angle. So what we would use for that is the cosine rule. And the cosine rule is a squared equals b squared plus c squared minus 2bc cos A. Starts off very similarly to Pythagoras' theorem, and then we have to subtract this 2bc cos A. This side will match the angle we are taking cosine of, and then these sides will be the other two sides, so not side A. We can rearrange this one. So this is a really good format for the equation to be in if we want to find the missing side. If we want to find the missing angle, we can just substitute the numbers into here and then rearrange, or we can use the rearranged version of the formula, which would be cosine A equals b squared plus c squared minus a squared all over 2bc. Now, we did an exercise in lesson a few months ago where we proved each of these rules. Can you pause the video, please? Have a go at proving these two rules, and then you should be able to check your book to see that you've managed to do that. Another important formula for a generic triangle, the reason I'm saying generic is it can't be isosceles, well, it can be, but we're not saying this is isosceles or equilateral or right angle. This is just some generic triangle. If we want to find the area of this triangle, we would usually hope to use half base times height. However, if we do not have half base times height, then the area will be half 2 of the sides multiplied together and then sine of the angle between them. So if we call this A, B, oh actually no, let's change that to B so that it matches this one as well. Let's call this B, A, C, and then this is angle C, this is angle A, this is angle B. For this one, we can just use half base B times height. But if we haven't got the vertical height, we need two sides and the angle between them. And then it would be half A times B times sine of the angle between them, and that would also give us the area of a triangle. So this is another one that you can try and prove. This has come up as something to prove in the GCSE exam, so it could well come up. We did this in lesson as well, so have a go at it and then check your answer against what you've got in your book. So pause the video now, have a little go. Don't worry if you're not getting these proofs, but remind yourself of them in your book. Now, the reason I wanted to talk about the sine and cosine rule is because when students learn about those, they tend to then try and use them whenever a trigonometric question comes up. So as soon as they see trigonometry, they think, oh, this is going to be a difficult question. I need to use cosine rule or sine rule. Please remember your basic trigonometry. Your basic trigonometry works within a right angle triangle. And we've got cosine, sine and tangent. So sine, cosine and tangent. Put E on the end there. So let's say we wanted to find this angle here. I'm going to call this angle alpha. Then this is the opposite side, this is the adjacent side, and this is the hypotenuse. And to find this angle, I can do that sine of that angle is opposite over hypotenuse. I can do cos of that angle is adjacent over hypotenuse, and I could do tan of that angle equals opposite over adjacent. These are still really useful and they will come up in the exams, and sometimes you will see a difficult question that looks like, oh, I definitely need to use sine or cosine, but you don't. You can just use these basic trig functions. So do remember these are really important. The last important piece on triangles I wanted to remind you of is one that gets very forgotten about once we've finished with it and we move on to trigonometry, but it's good old Pythagoras' theorem. If we have a right angle triangle with sides A, B and C, we know that C squared equals A squared plus B squared, and we can rearrange that to get A squared equals C squared minus B squared, or B squared equals C squared minus A squared. So do not forget about Pythagoras' theorem. Right, what I'm going to do now is I'm going to show you an exam question that demonstrates what I said earlier about students wanting to go for cosine and sine rule when they don't need to. So this is an exam question. It shows you a quadrilateral, JKLM. And the question wants us to work out the size of angle KLM, so this angle. Now, lots of students in my last year 11 class looked at this and they saw that we had an angle and an opposite side. So they thought, okay, we will find this side here and then we'll use it to find this opposite angle. It's a good start to the question. We don't have enough information about this triangle here, but we do have quite a lot of information about this triangle here. The first thing that we want to use, well, you pause it and have a go if you want to, or if you're not sure, you can carry on watching. But the first thing we are going to want to do is to find this side here. And the way that we're going to find this side here is just using Pythagoras' theorem. This is a right angle. So this side here, which I'm going to call x is going to be the square root of 7 squared plus 4.5 squared. Once we've worked that out, we get that x is equal to 8.321 blah blah blah, and we're going to save that number in our calculators because we want it to give us the most accurate value here. Okay, so we've got this angle, this side, sorry, opposite this angle, and this side opposite this angle. So let's use the sine rule, right? We absolutely could do, but this is a right angle triangle. So why don't we just use normal trigonometry? We've got this angle is what we want. We've got the hypotenuse, and we've got the opposite. So if I call this alpha, we can actually just say that sine alpha is equal to x, which is this 8.32 blah blah blah, over the hypotenuse. So it's equal to 8.321 da 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 over 15, which means that this angle here is equal to sine inverse of 8.321 blah 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 over 15, and I don't have my calculator with me here, 10, as I often don't, so whatever that answer is will give us that angle. But the point of this question is, this is just two right angle triangles. So even though you've learned about the sine rule and the cosine rule, all you actually needed for this quite challenging question was Pythagoras' theorem and then standard trigonometry. I'm going to put up some questions on all of these different things I've talked about today as revision for next week. So there will be questions using Pythagoras' theorem, standard trigonometry, sine and cosine rules. So have a go at them, but think very carefully about how are you going to make the question as easy for yourself as possible. We could have started using sine and cosine rule here, but there would have been no point at all. For example, some students, when we went through this question, started trying to work out all of the angles and then finding this one by taking the rest away from 360. That would work, except that it's quite tricky to work out this angle without just getting to these two values, in which case you could just work out this angle. So think about what is the easiest way for you to get to the answers for these questions, because sometimes you will not need to use the more complicated methods. Don't forget about Pythagoras' theorem and standard trigonometry just because you've learnt the sine and cosine rule, but do make sure that you have committed the sine and cosine rule to memory. Okay, if you have any questions on any of the problems that I put up, then please just comment on Show My Homework and I will help you through them.